Hello, welcome. We're in Algebra 1. We're in the second learning target about linear equations and their graphs. And we're going to talk about how to create slope-intercept form with an equation when it does not begin like that. Let's go ahead and get started. So you can see at the beginning we have the second learning target. And then following that, it talks about how some linear equations don't come in the convenient y equals mx plus b form. The trick is to solve the equation for y and then graph. So let's do several examples. First of all, we've got this equation, negative 2x plus 3y equals 12. I'm going to go ahead and just rewrite it here. First step towards solving for y, meaning making y alone on the left, is to add the 2x to each side of the equation. What that will do is that'll zoop cross off the x from the left, and then on the right we'll go ahead and we will write it as 2x plus 12. It's tempting to try to combine the 12 and the 2x, but they are not actually like terms. One of them is a constant with no x's, and the other one is a linear term of x's. They don't actually go together. I also recommend that you put the x term in front with the constant at the end. Once you've done that, you'll need to divide by 3. And there's a small trick here, which is that each of the terms on the right need to do that divide by 3 business. So the 2x divides by 3, and the 12 divides by 3. So when you take the 2x and you divide by 3, it creates 2/3 x. When you take the 12 and divide by 3, well, that's 4. So I'm going to just go ahead and rewrite it at this point, just all in one color, so it's clear. Circled it to make it look good. The circling isn't important, though. And then, just to help us out, let's rewrite that the slope is 2/3, and the b value, which is the number for the y-intercept, is 4. Okay, now, go ahead and get the graph down. This should be review. Boop. We've got ourselves a dot at 4, because the b value is 4. And then from there, up 2 over 3 to get the second dot. And then, because I like to go backwards, down to left 3 to get the third dot. And then zoop, zoop, line, arrows, happiness. Okay, let's try the next one. 8x plus 4y equals negative 4. We're going to begin solving for y, which means we've got to get everything that isn't y away on the left, and we can go ahead and do that by subtracting 8x from each side. When we do that, the 8x's are gone on the left, so we have 4y equals, and on the right, negative 8x minus 4. Again, they are not like terms, they don't actually combine, and I recommend you write the x term first, followed by the constant term. Need to divide by 4 on each side to finish solving for y. As a reminder, when we do that, that means each of the pieces, each of the terms is divided by 4. So it's actually negative 2x and then minus 1. Again, I'm just going to rewrite it all in the same color to take away the chromatic distraction. Circled it for flair. And then as a quick reminder, the slope is negative 2, which is negative 2 over 1, and the y-intercept is negative 1. All right, good times. Let's go ahead and dot at negative 1. The slope is negative 2, so down to right 1. To go backwards, up to left 1, and then zoop, zoop, line and arrows. We're making progress. Here's another one. 6x minus 3y equals negative 15. Okay, we're after solving for y, so I'm going to go ahead and subtract the 6x from each side first. And the 6x's are gone on the left. Notice, though, that it's negative 3y that's left over on the left. You might have thought of it as minus, but I really need you to understand that that's really just negative 3. So it's negative 3y on the left, and we have negative 6x minus 15 on the right. From there, go ahead and divide by negative 3. That means each term divides by -3. So we have positive 2x plus 5. Okay? Again, just once more, all together now. The slope is 2, which is really 2 over 1. And the y-intercept is at 0, 5. There's our first dot. All right, now up 2 over 1. Down 2, left 1. We've got a positive slope, positive 2. Boom, we've got a graph. All right. Now, those first 3 examples came in or close to what's called standard form. Don't worry about that too much. But notice here, for example, 4, that all of a sudden it looks different. So we have to remind ourselves of some equation solving techniques. So I'll just go ahead and rewrite it. Y plus 4 equals 1/2 times the quantity x minus 3. Now that 1/2 in front of the parentheses needs to be distributed. So a couple arrows showing that it rainbows, as I like to say, into the expression. So I'm going to go ahead and rewrite it. On the left, it's y plus 4. On the right, it starts as 1/2 x and then minus 3/2. You might need to use calculator to multiply that confidently. That's not a problem. When we do that here, we have a different beginning outcome because it says y plus 4. So in that case, we don't need to move any x terms. We just need to subtract 4 from each side. All right? Subtracting 4 from the right makes it intermingle with the negative 3/2. So we have y equals, the 1/2 x is untouched, and then that makes negative 11/2. That again might be calculator work for you. Please let me know if you need help using your calculator well. Okay, we got 1/2 x minus 11/2. So the slope is 1/2. The y-intercept is negative 11/2. And since we're talking about y-intercept numbers, you might actually be happier writing that part as a decimal. So negative 5.5. Because then, boom, you've got a dot at negative 5.5 on the y-axis. Then from there, up 1 over 2. Up 1, right 2, more specifically. And then to go backwards, down 1, left 2. Then zoop, zoop, arrows, straight edge, line, boom, happiness. Now, those are some examples of solving for y first, meaning making the equation say y equals, and then using our understanding of slope and intercept to get the graph down. Notice, though, something else I need you to try to take away today, which are these special case lines. If it's just one variable in the equation, they're horizontal or vertical lines. We've got a couple examples here. First of all, let's start with the line x equals negative 4. Now, there's a rule for it. In fact, it's actually already written on your notes, but just to help us out, it might be useful to think of what are some points where x equals negative 4. So I just threw down some examples. Ooh, like negative 4, 0. That's a point where x equals negative 4. Here's another one. Negative 4, 1. Negative 4, 2. All points where x equals negative 4. You might be getting bored now, but hey, negative 4, 3. Yeah. Okay, going even farther would be insane. Let's go backwards. How about negative 4, negative 1? Oh yeah, x is still negative 4 for all these points. Negative 4, negative 2, sure. Although we don't need to keep going forever. So, ooh, let's go crazy. Negative 4, negative 6. All right, those are some points. Boom, 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 boom. Okay, we've got some dots. If you connect those dots, you get a line. So, when the equation says x equals a number, and there's no y in the equation at all, just x equals a number, it is a vertical line at that number. There is the other kind of special case line, though, and that's when it says y equals a number. In this case, like in this case, y equals 5. Let's throw down some sample points. This time y is 5, so how about, 0, 5. Always start with 0. 1, 5. Yeah, because, the y is 5. 2, 5. And 3, oh no, let's go even crazier. 6, 5, yeah, y is still 5. Oh, backwards, negative 3, 5. Sure, why not? The y is 5. Yeah, negative 9, 5. Negative gazillion 5, but that's not going to fit on the grid. Hey, we've got these points, so we can go ahead and say dot, 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 dot. Those are the points. Connect them up. Zoop, zoop. Boom, you've got yourself a horizontal line at 5. So when the equation is y equals a number, and only a number, there's no x's in there at all, it's a horizontal line at that number. Just like when it was x equals a number, it's a vertical line. When it's y equals a number, it's a horizontal line. Well, that's all for today. So thank you for watching, and please let me know if you have any questions. Thanks again.